Nope. We're going to do this. I did. All right, so I just call this day one. This is supposed to be chapter 4 and 5. I did chapter 4 in the first period class, or the period before you guys. So so watch the chapter 5 review. Okay, if you want to watch the chapter 5 review, it's already up. It's on, well, this is already up too. So I should just say, just watch it on your own. But you are in class, so we will go over it. Here we go. Let's change color. I don't know if we'll even be able to finish today, but we should get close. All right. Classified by the angle measured. And even if you don't have to take the test, come on, let's play along, participate, help out. All right. So I'm not just talking to a blank wall. All right. So it says classified by the angle measure. So look at this right here. What kind of triangle is this by the angles? It's a right triangle, correct. It's right because it got a right angle there. So that's what you would put. You would put right triangle. All right, that's by the angle measure. What about the sides? I got two equal sides. What do we call a triangle that's got two equal sides? It's an isosceles triangle. So you got two answers to this. You got one by the angles, one by the sides, so that's isosceles. All right. I'm going to skip a couple of these because there's a couple that are kind of the same, you know, like that. If you really, really want to watch it, then watch it on the other class. This, we'll just say it. I'm not going to write it down. But by the angles, what is this by the angles? Equiangular. You could also say acute if you wanted to. All right, but don't just put equiangular and acute because that only describes the angles. You also have to describe it by the sides. So all three sides are equal, so you could call it what? Equilateral. Equilateral by the side length. If you wanted to call it isosceles, you could. Why is this also isosceles? Because at least two of the sides must be equal. We usually just stick to two of the sides are equal, but there you go. All right, what about this one? It's pretty. If you put isosceles, yeah, I'd give it to you. If you put acute for the angle and isosceles for the sides, that would be okay. But what I'm really looking for in this problem is equilateral and equiangular. Actually, the other way around. Equiangular first, angle, and then the side would be equilateral. All right, let's do this one. Find the angle measure, angle A. So we've been doing stuff like this even after we taught this thing, right? Way after we taught it. So should be something you should be able to do, pretty easy. I'm not going to show the work. I'm just going to, because of time. So you add up these. It's 140. Take it away from 180. What do you get? 40 degrees. All right. And how do I find this angle right here? That's ACD. There's A, there's C, there's D. Just take it away from 70, or take 70 away from 180. So 180 minus 70 is 110. All right, let's go to these. It's been a while since we've done these, and we really haven't done anything like this since we did this chapter. All right, so it's not fresh in our minds. You can always do this. I gave my other class this suggestion. If you're struggling with this right here, go to the review, the chapter test review. Okay? So scan through it until you get to chapter 4. There should be a review for the chapter 4 test. I probably go into a lot more detail on that. So that would be a good resource for you. All right? So we got to write a valid what? Congruence statement. And then we have to name the postulate. So there's two parts to this question. The congruent statement is, I'll tell you what, let's do it opposite. Let's do the postulate first, then we'll do the congruent statement. So why are these two triangles right here congruent to each other? Remember the angle, side, angle, side, angle, side, 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 side stuff? Yes? All right, that's what we're doing. So there's an angle, there's an angle. What else? They don't really tell you, but it's in the picture. What else is equal? This side right there, okay? So I could put the side there. So look what I got. I got an angle, I got a side, I got another angle. See it? I got one arc, one side, two arcs. Look over here. I got one arc, one side, and the two arcs. So these triangles are congruent because of what? Angle, side, angle. Now, we got to write the congruent statement. Again, I think I'm only going to do one of these because of time. I do these two in the other class. Go back and watch them if you want. All right, so what do you want to call this one? We'll call it WXY. I could have used any of those three letters in any order. It doesn't make any difference. I just decided I think it would be easy to go WXY. And this is congruent to triangle. Now watch, I go WX then Y. W's got the one arc. What angle down here has the one arc? It's the y, so we put the y first. The x has no arc. Which one down here has no arc? The z, so I put that. And then, which one has the 2 arcs, right? Because this is a y. Which one has 2 arcs over here? The w, and that's how you do it. All right? So it's 2 answers to get that right. You got to have both of those things. The congruent statement, which is this first thing, the postulate, which is this thing right here. All right? I did number 6 and 7 in class with the other one, with the other class, so there you go. Let's do this one. This kind of messed people up when they first did this test, but let's try to figure it out. It says, what additional information is required to know that the triangles are congruent to each other? All right, well, they only tell you this angle is equal to this angle. That's it. But there is something else we just talked about earlier. Okay, if these 2 triangles, okay, if you want to say they're congruent to each other, what must be equal? That side right there, that BD, it's shared by both of those, isn't it? Even if they weren't congruent, that's still shared by both of them, so it's still equal. So what's an additional? What's one more thing that we would need to know to say that these 2 triangles are congruent because of angle side angle? Right, this angle is given, this side is kind of given, right? What's the other angle? It's this one right here and this one right here. I can't just say angle B though. What do I have to say? Angle A, B, D, right? So I got to go angle ABD would be equal. What's this angle down here? Since I went A first, what am I going to do here? Let's go C, B, D. Angle C, B, D. Does that make sense? That's the additional information. That thing in red, right here and right here. This really isn't additional. This is, they gave it to you. You can see it on the picture, correct? Same thing with this one, right? You know that that's equal to each other. What about this one? You know that these 2 angles right there are equal. So those 2 things aren't additional information. They're information that's already given in the picture, okay? You just got to find additional information. All right, let's keep going. So this one is kind of like side angle, and all that, except this is what we use for right triangles. We got leg, leg, hypotenuse angle, leg angle, and hypotenuse leg. So I give you the options. That's nice, isn't it? All right, you see the options. So you really got a 1 in 4 chance to get it right. But let's get a 4 in 4 chance to get it right. Write an angle congruence statement and name the right triangle congruence theorem. So just like this, we're going to have a congruent statement and we're going to have a theorem. Let's do the theorem first. Let's find out why they're congruent to each other. Why is this triangle congruent to this triangle? Well, they both have a right angle, which means we can use any of these. And they also have this side, just like we've been doing on the other ones, right? It's shared by both of these triangles. What is this side, though? This is a hypotenuse, isn't it? Because it's opposite the right angle here, and it's opposite this right angle, so that's a hypotenuse. So that kind of narrows our choices down, doesn't it? That narrows it down to either hypotenuse angle or what? Hypotenuse leg. Well, what are those 2 arrows right there? What does that mean? It means they're what? They're parallel to each other. If you remember, you got parallel sides, you got a transversal. That means the alternate interior angles are equal to each other. Okay? Now, check this out. Now I have a hypotenuse, and now I have a what? An angle. So which one am I going to use? Hypotenuse angle. Does that make sense? All right. Now we got to write a congruent statement as well. Let's just do that real quick. So what do you want to call this triangle right here? Call it ABC. It'd be easy, wouldn't it? ABC is congruent to triangle. Now if I start at A, where am I going to start off over here? I'm going to start off with C. Then I'm going to go what? I'm going to go C, then B, which is the right angle. D is the right angle here. So I go C, D, A. All right? So that's how I would do that. Again, 12 and 13 are kind of like this. So let's just move on since I only got 5 more minutes. What about this one? Find XZ. This side right here. I got to find that. Well, I'm not going to call it X. Whatever. We'll just call it XZ. All right? You remember this? This is a mid-segment. You remember that word? Okay, it's a segment that connects the midpoints. What do we know about the mid-segment? Well, we know 2 things. We know that it's parallel to the opposite side, and the mid-segment is half of the other side. So if this is 7, what's this going to be? It's It's going to be 14, because remember, the mid-segment is half of the third side, all right? So it's not 3.5, it's half, 7 is half of that side, so it's got to be 14. Why? We're in the middle of a review. You can call her after class is over. I know. You can call her after class is over. All right, so there you go. So that's 7, that's 14. What about right here? This is just as easy. If this is 24, what's this from here to here? That's a mid-segment, so that would be what? It'd be 12. Super easy. Those can be done in a matter of seconds. You really don't even have to show work for that. Just write the answer down. Look at this one right here. This one's a little bit different. You definitely got to show a little bit of work with this, but we're going to use the same idea. Now, you could say the mid-segment is half of the other side, the opposite side, or you could say the opposite side, that third side, is twice as big as the mid-segment. Would you agree? This is twice as big as this. This is twice as big as this. So 3x minus 8 is what? Twice as big as x plus 2. So let's write that down. 3x minus 8 is twice as big as x plus 2. That's just a little easier to use the 2 than a half. Would you agree? If you did the half, you would say x plus 2 equals half of 3x minus 8. I just think it's easier doing it this way. All right, so let's do the math. 3x minus 8, distribute 2x plus 4. Subtract 2x from both sides. Let's do a little on our head here. Subtract 2x, so 3x minus 2x is x. Then we add an 8 to both sides, add an 8 here, add an 8 here. That gives us 12. Do I circle that? Is that my answer? No, because they want you to find what yz is, the length of yz right there. So what do I do with that 12? Plug it in for that x right there. So it's just 12 plus 2, which is 14. So the length of that is 14. Is it coming back to you? All right. What, this part right here? Yeah, that was pretty easy. Good. Well, at least you remember how to do it, so that's good. What about this? Slope. Do you remember slope? It's been a little while since we've done slope, okay? We have done it since that chapter, okay? We have talked about slope after that chapter, but let's talk about it now. We use m for slope, remember that? And then y2 minus y1, x2 minus x1. Very good. So that's definitely something. It sounds like you guys remember that, so that's good. Well, you can go y1 minus y2 as long as you go x1 minus x2. All right, you got to make sure that if you subtract that in a certain direction, you got to subtract that in the same direction. Okay, so let's do it. Let's do DE. Well, the problem is finding the slope of DE. I don't know that point right there, do I? And I don't know this point right there. But what we can do is remember that if these two, I said it earlier, there's two things that we know about the mid-segment and the third side. What did I say the first thing was true? They're parallel to each other. So if these are parallel to each other, what's going to be true about the slope? They have the same exact slant, don't they? The same slope. So if I can find the slope of AB, then what's the slope of DE? It's the same thing, okay? So what I'm going to do is I'm going to find the slope of AB first. I'm going to get an answer, and then DE is going to be the same exact answer, all right? Pretty easy, right? So AB, let's find the slope, right? Subtract the y's. Let's just go this one minus this one. Does it matter which one we do? Which order we go? No, as long as we do it in the same order. So I'm going to go -1 minus 5. Those are my y's. Then I take my x's and I subtract those. That's -4 minus 6. -4 minus 6. This is -6 over -10. The two negatives make a positive. Reduce it. It's 3/5. So that's the slope of this one, correct? So what's the slope of this one going to be? It's going to be the same thing. So it's going to be 3/5 as well. So both of these are 3/5. All right. I got time. Maybe I got time. I got like 1 minute left. Can I do this in 1 minute? In 1 minute? All right. Find the length of each segment. So the length of that segment is the distance between these 2 points. So what formula are we going to use? The distance formula, okay? So x1 minus x2. It doesn't matter what order you subtract the x's in this one. y1 minus y2. But we are subtracting, okay? So now that's our formula. Again, put a box around it. We got to memorize it. Now let's put the numbers in. So I like to do this first. And let's put the numbers in. Let's see. What are we going to do? Right here. Same numbers, right? So it doesn't matter what order you put them in. Let's just do the x's. So that's negative 4 minus 6. Let's do the y's. Negative 1 minus 5. We already did this math already. That's negative 10. What's negative 10 squared? That's 100. This is negative 6. What's negative 6 squared? That's 36. That's all under a square root. So that's the square root of 136. Now this can be simplified, but I'm not, just keep it like that. That's perfectly fine. So that means this length right there is the square root of 136. You don't even need to put it into a calculator, okay? Just keep it just like that. Just making it easy for you, all right? Now, how do I find this midsegment then? This is how much of this? It's half of it. So how do I take half of something? Divide it by 2. So all I do is take square root of 136 divided by 2. It's not the most simple way to write it. You can simplify this square root. We really haven't talked about it too much. We talked about it just a little bit this year, but just keep it like that. That's perfectly fine. Okay, don't put it into a calculator. Don't get me a decimal. Just keep it square root of 136 over 2. Now, what if this came out to like the square root of, I don't know, 400? Yeah, that can simplify. What does that simplify to? What times what is what times itself is 400? 20. 20 times 20 is 400. Agreed? All right. So this would be 20, and this would be what? 10. All right. But if it comes out real weird like that, just keep it like that, and you're good to go. Please watch. I'm not going to grade it right now.
I'm ready right now.
Well, I'm sorry. Right I'm sorry. I'm not. I am not ready right now. Watch the Chapter 5 review on the other class's YouTube page. Okay? YouTube. Everybody got that? Watch the Chapter 5 review on YouTube. I'm not going to go over that. We're going to start with Chapter 6 tomorrow. Everybody good?